Everybody, we're here tonight to look at mobile app test automation for Android. Tonight we're going to be using TestEvolve Spark, the Ruby variation. We do also have a JavaScript or TypeScript flavor, but tonight we're going to look at Ruby. Maybe we'll pick up on JavaScript next time round. Amongst other things, we're going to be looking at the management of your APK files within the context of your automation project. As you inspect the application under test, we'll be looking at different types of page objects and the element locator strategies you might choose to employ in certain situations. And then we'll be looking at the choice you make or the strategy that you employ when it comes to deciding whether you're going to be working with emulators, physical devices, or more of a cloud-based solution, something like BrowserStack or Source Labs for your CI/CD. For the execution of your tests, and ultimately then the reporting that you have available to you as well. Okay, so that's the focus for tonight's session. All right, let's jump in. So just in terms of workflow this evening, we'll start with a look at the kind of sequence that we're going to be following in this session. Okay, so whether you're brand new to Android or native app automation, or just getting started with TestEvolve Spark with an evaluation maybe, this is almost certainly the easiest way to get up and running. We're going to move through 4 key stages. Okay, so the install, the exploration of the app under test, the writing of your tests, and then the running and the reporting of your tests. Okay, so we'll start with getting the tools installed that we need. So we're going to need Ruby, we're going to need Appium, Android Studio, etc. And we'll explain the part that each of those plays in due course. We'll explore the app using Appium Inspector. We're doing that so we can retrieve elements to start setting up a working test session. From there, we'll then begin writing our tests with TestEvolve Spark Ruby, okay, and the elements that you captured under your Appium inspection. And then we'll run the tests, of course. We'll look at emulators, physical devices, and then optionally via a platform like BrowserStack, if that's going to become part of your CI/CD strategy. So I'll walk you through each step in more detail as we go. Good, right, let's look at the setup side of things. We'll start with the install of Ruby. Okay, so you will need Ruby. If you're on a Mac, in fact, in either situation, you can come onto our documentation. So you'll find us at testevolve.github.io. Within that, you'll find the Spark setup, the quick start guide here, as you can see in the navigation. That's going to tell you where to go in the event that either you're on a Mac or a Linux OS, or you are a Windows user. With Mac and Linux, we can use RVM, so that's Ruby Version Manager, to manage our Ruby versions, as you'd expect. With Windows, we suggest that you go to rubyinstaller.org. So if you're looking at RVM for Mac or Linux, you come to rvm.io. We would recommend that you install the latest stable, so you can do that with this command here in a terminal session. If you're on a Windows machine, then pop on over to rubyinstaller.org, come into the download archive section, and we are currently supporting versions Ruby 3.2.4 at the time of this webinar. All right, so that changes fairly frequently, but now 3.2.4. Once you've installed Ruby, come across to testevolve.com, and at the top right here you can click on try TestEvolve or a free 30-day trial. That's going to take you to a sign up page. No card details required, completely free evaluation for 30 days, and that's the framework you're going to see tonight that we're basing this webinar upon. So come here, just pop in your organization ID. That will then give you a URL for your reporting platform. So every time you want to see your reports, the output of your testing, this will be the URL that you would go to. Okay, so normal registration process, you'll be sent an email, there'll be a token that you can use to set up your password and sign in. And once you do sign in, you'll be presented with a projects page, and from there you can come to the download section. And Flare is our Studio IDE type application that's going to allow you to do some project setup. Okay, so you can go there to download Flare. You can also get it from our website under the resources and the downloads section over here. Okay, but once you've got Flare, so this is Flare here, it's an Electron application, so it works beautifully well across multiple operating systems, of course. You'll come in, you'll sign in here with the same credentials that you registered your company with for your evaluation. Okay, so let's just sign in. We're going to use Flare to create this new Ruby automation project within which we're going to be working tonight. All right, so I'm going to sign in. Okay, and then I'm going to create a new Ruby project. Okay. Literally going to call it a new Ruby project. I'll choose my directory. And I've got a choice of language here, Ruby, JavaScript, TypeScript. Well, tonight it's going to be Ruby. So create project. And that's going to go ahead. It's going to check the Ruby install that you've just done. It'll check the version, the evaluation version of TestEvolve that you signed up for. Make sure you're going to download the necessary Ruby libraries, that everything is required, and then bring you to this homepage. So at this point, you've now got a TestEvolve Ruby project to work within. Okay. So the next things we're going to need to look at, this is focused on Android native app automation, of course. So there's definitely a few core tools you're going to need alongside those that we've just done. Android Studio is essential. So Android Studio is going to give us the Android SDK itself alongside Emulator support. We're also going to need an Appium inspector to explore the app's UI elements and to generate those locators that we need for the test. This will give you ADB, that's Android Debug Bridge as well. So this lets us communicate directly with the devices and the emulators once they are active. So that's key, of course, for running tests and for troubleshooting, the ability to connect to that device. And finally, Visor. Visor is optional, and we'll look at that shortly, but it can be helpful if you want to view a physical device on your actual screen, or certainly if you want to share what's happening on your physical device with others on a call, for example. Visor can be a great platform to do that from. All right, so once everything is installed and running, and then we can move ahead. Just for reference, for Android Studio, you're going to come over to developer.android.com. Of course, you can Google that. Latest version, it's Android Studio Meerkat. And then for Appium Inspector, you're actually coming into GitHub, so github.com. Google that. It should take you to this page, Appium Inspector. All right, and then just follow the download and the install instructions for Appium Inspector. All right. So focusing on Android Studio for a second. So once you've completed the install and you fire it up, it's going to look a little something like this. So it's our main development environment, essentially, not for building the app, of course, but for accessing tools like the Android SDK and the emulator itself. So on the left, you can see the Android Studio interface. In the middle, or the option we're going to choose from that More Actions menu, and what we see in the middle is the VDM, the Virtual Device Manager. So we use this to create and configure emulators. So to start with, you probably won't have any, so you're going to use this as a means of setting up an image of a particular device, an Android device that is going to meet your requirements. Once you've done that, and of course you can install more than one. I've got a range there, some old through to some new, so a Pixel 5 through to a Pixel 9 Pro. I can use them for different reasons, of course. There'll be different circumstances in which I'm going to want each of those potentially, either because it's just the latest out, or because it's something I know my customers are using, or because someone's had a particular issue on a particular phone. So many different reasons for targeting particular devices, but the virtual device manager is where you come to do that, and also where you get that device up and running effectively. So you set that device up and start it effectively. All right, so that's what we see on the right hand side. That's what it will look like when you start that emulator. All right, so that becomes our virtual device for testing. So emulators, sorry, I should say, are great for getting started. All right, it's always important that you are going to test on devices that, of course, are going to reflect what your user base is actually using, the devices your customers have. So if you do have any kind of analytics data, try and use that to the best of your ability to target your devices and your testing. Check which Android versions, which device models are most common amongst your users, and then set up your emulators to match that. So it's certainly going to help to make sure your automation is more meaningful and definitely more aligned with kind of real world usage, if you like. Moving on, let's have a quick look at Appium Inspector and Visor. So again, Visor is optional. You definitely don't need that, but it can help if you do effectively want to broadcast any activity from a physical device onto your screen for whatever reason. All right, so on the left we've got Appium Inspector. So this is what we will use to explore the structure of our application under test. So to inspect the elements and to test those locators before we begin, or the things that we need in order to begin writing these end-to-end tests. Before you can launch an Appium Inspector session, so through the terminal you will need to start an Appium server session. All right, so that's Appium -P and then a port number, let's say 4723. And then we'll be able to connect the inspector to that port. And the link there allows the inspector to launch the application under test on your emulator or on your physical device in order to then begin that inspection session. Okay, so you'll see capability builder. So this is where you're going to enter values like the platform name, the device name, the relative or the absolute path to your APK. So we'll look at that when we talk about the APK management within the automation project. And then your chosen automation engine. So most commonly, well, almost all the time really for Android, these days it's going to be UI Automator 2. And we'll talk about that in just a second. With other mobile platforms, namely iOS, will be using a different engine. And then you have, if you're more on the development side of things rather than the end-to-end testing, again there's another engine called Espresso. So I'll talk to you about those in just a second. On the right there, that's where you'll see Visor. As we say, completely optional, but great for mirroring and controlling a physical device from your desktop if you decide that you need to do that. All right, so with all of these, you can have great visibility of the app internals, if you liked, and a direct interaction with that device, whether it's on an emulator or whether it's physically tethered to your machine. Okay. I talked about the UI Automator 2 engine. So what is this? It's the automation engine we'll be using to drive any kind of native app Android testing. Is really powerful. So UI Automator 2 is going to allow for system-wide testing firstly. So it can interact with not just the app under test, but also other apps, other Android system UI components without any need to access their source code. So it supports very flexible element selection using something called UI selector. So this helps us find elements by things like text, by content description, by class name, or the resource ID. It also gives you powerful scrolling features. So the UI scrollable feature lets us automatically scroll through really long lists or long pages to bring these off-screen elements into focus if we need to do that within the test. And it's all available through the UI Automator 2 driver. All right, so it lets us combine these capabilities with Appium's cross-platform framework, if you like. And then the UI device class gives us low-level control. So if you need to do things like simulating the pressing of hardware buttons, taking screenshots, rotating the screen, for example, that can all be done through UI Automator 2. Now, I mentioned two others. Okay, so for all modern Android app automation, you're almost certainly going to be using UI Automator 2. There was UI Automator that came before it, but that's essentially deprecated now, or for very, very old legacy Android applications, very unlikely to be needed in 2025. If you are, and that's not the point of this session, but if you are looking at iOS testing, the Apple equivalent is something called XC UI test or XQE test. It's the Apple official automation framework, very tightly coupled with Xcode, but you wouldn't need that for iOS testing, so maybe another webinar there. But coming back to Android, if you're more on the developer side, you also have Espresso, which is an engine you can download, install and use to drive your automation. Built by Google, but designed for fast, reliable automation within a single app. But it does require access to the app's source code, right? So a slightly different entity in that regard. Mostly used by developers or maybe testers working inside the app development team as well, but not so much for your end-to-end testing. All right, so we're going to focus on UI Automator 2. It's a great fit for essentially black box testing when you couple that with Appium. Okay. So one thing you're going to have to consider once you've got your tests up and running, or certainly while you're developing your tests as well, is the use of emulators versus real devices. I think really there's always going to be a time when you need both, but they certainly both have kind of pros and cons, or they have their strengths. So focusing on the emulators to start with, I mean, the biggest thing effectively is that they are cost efficient. Okay, you can spin up as many as you like. They're great for testing across a wide variety of screen sizes, Android versions, and API levels, for example. Of course, they integrate nicely with the development tools. They can and they do support your network simulation, good for quick debugging and CI pipeline usage. They're consistent at the end of the day, and easy to reset with this idea of virtual device snapshots. The obvious downside, of course, is that they're not real hardware. They're not what your users are actually using. So things like performance metrics or touch interactions, some hardware integrations are just not possible or not reliable if they are. And of course, that's where real devices then come into their own. So if you are also looking at actual app performance, you're looking at testing battery usage, or checking how your app behaves with interactions with cameras, with GPS, with sensors, etc. Fingerprint authentication. That's when you're really going to need a physical device. Now, some of that's more prevalent when it comes to kind of manual testing of the app, not so much from an automation perspective, but just something to be considered nonetheless. So I think real devices will also let you validate manufacturer specific behavior like OEM UI customizations, and helping you to ensure that you're actually testing under real network conditions, real gestures, etc. But I think number one reason for real devices is that that's what your users are using. But of course, it can be costly and somewhat ineffective to try and manage and maintain an internal device farm, one that's going to be outdated very, very quickly. So yeah, I think in short, emulators for fast iteration, broad test coverage, real device is essential for validating that real world user experience. Before we start getting into the coding side of things, let's just finally talk about a third option you have. So this may well also, probably quite likely in some respects, to come into your mobile app CI/CD testing strategy at some point. And maybe you already have a subscription to these types of services. Okay, but a third option you have, more so for testing at scale, and it really gives you the best of both worlds of real devices, but in a way that you don't have to maintain your own device farm itself, is the use of a service like BrowserStack or Source Labs or Cobaton. All right, so cloud device vendors offering both real and virtual devices. All right, so yeah, it certainly gives you the benefits of the service without the cost, without the hassle. So it's a good middle ground. They give you access to hundreds of real devices across multiple manufacturers, of course, different screen sizes, Android versions, mostly all available on demand. Sometimes maybe the most popular model is a little harder to get hold of on demand than a slightly older version, but generally speaking, you're not going to have any issue getting any kind of device that you need for your Android testing. Very, very cost efficient. You're not buying, you're not storing, maintaining, you're just paying for the service. Another main advantage really is the ability to test at scale. So your price packages with these types of services will give you concurrency options. So depending on what service you go for, you can run multiple tests in parallel across different devices. That can save a huge amount of time, of course. And they're all going to give you some enterprise type capabilities as well. So your session recordings, videos, the logs, geolocation testing, network simulation. So all of these can support your testing, but add a great deal of depth to it as well. Okay, very much designed to integrate closely with your existing CI pipelines, your test automation frameworks, of course. So with Test Evolve, we have a number of those integrations ready to go. So tonight we'll look at what we can do with BrowserStack as well, with almost no setup other than the provision of an API key for your subscription, if you like. And of course, when things like security and compliance fully baked in as well. So these platforms are built to handle enterprise data safely, and with the automatic management, clearing of session data between runs, etc. So yeah, if you want flexibility, scale, it's well worth thinking about this type of service for your CI/CD mobile app testing. Going to look at the process of exploring the app now, in order to capture your elements so you can start writing your tests. Okay, so we went through the install side of things earlier on. The first thing we're going to open up is Android Studio. So when you open Android Studio, it's going to look a little something like this on the left hand side. From the More Actions menu, you'll have something here called a Virtual Device Manager. When you click on that, it's going to open up a panel like we see on the right hand side here. Now, to start with, you may have no images or virtual devices in there. You can always click on this plus button in order to create a virtual device. That will bring you up the Add Device modal. As we said earlier, you're going to want to create an image of phones that are reflective of what your user base is actually using. All right, so there's a variety of phones. You can do tablets, desktop, various different things, and create custom images. But essentially, this is probably your start point. All right, so if I close that down, you can see I've already installed a number of images, Pixel 5 through to Pixel 9. I've actually fired up the Pixel 7, so I'm going to focus on that for the rest of this session. And so the next thing I'm going to do is open up, excuse me, Appium Inspector, okay? And I'm also going to have a terminal session ready to go. So first thing I'm going to do here in my terminal session is fire up Appium itself on a particular port. I'm going to make reference to the port we see here at the top, 4726. So I'm just going to go Appium -P4726. Enter that. And that's going to start an Appium server session. As we can see there, makes reference to a couple of drivers. We already mentioned that we'll be using UI Automator 2 for this. And then I'm about to start an Appium Inspector session here. So I don't really need the terminal. Excuse me, I don't need the terminal. I keep it around, but I don't need it any further at this stage. I'm now in Appium Inspector, and where I'll be going is Start Session. Before I do that, I need some capabilities. And if you've done any kind of automation before, especially with things like Browser Stack, you'll be familiar with the concept of, or WebDriver, to be honest, the concept of capabilities, a set of instructions, configuration as to how you need that driver to run. So as far as Android is concerned, there's not too many, but we're looking at platform name, which in our situation is going to be Android. We have a device name. In fact, I will show you this. I'm going to open a separate terminal session. We are going to need the device name. Let's just bring that up here, and let's create a new terminal quickly. We're going to need the device, or the name of the emulator that we've just opened up through Android Studio. So I can simply go ADB devices. I can enter that, and you see there I get reference to something called Emulator 5554. Okay, so that is this guy over here on the right hand side. If I clicked in a physical device, if I was tethering to a physical device, which we'll look at a little later on, I would have a different reference there, and that's what we call the UDID, or as far as Appium capabilities, it's the device name. Okay, so I've got Emulator 5554 in there, and then Appium app, the app property. So we talked about management of the APK files. So if I open up in an IDE, in my case it's RubyMine, but you might be using Visual Studio potentially. But if I open up the project now that we created earlier through Test-Evolved Flare, all I'm going to do is drop my APK file in the root of my project. That's all I need to do, nothing else. But when I come back to Appium Inspector, let's get the right one, there we go. I'm going to put that full path to the app within my automation project in this Appium app capability over here. All right, we come down, automation name, well that's going to be our driver, our engine of choice, which is UI Automator 2, as we said, for all modern Android app testing. And I've also got another parameter set here called no reset true. Okay, what you'll see on the right hand side, it creates a JSON representation of that. I'm now free to go ahead, start that session, and what Appium is going to do is install and open that application on my emulator device on the right hand side. So we're just going to wait for that session to kick in. Okay, and there we go. So it installs and opens up my app. And there you go, it starts to give me this visual representation of my app on the left hand side. And very simply, simple terms, it's a case of what I tend to do is drive the app from the right hand side. I can click on things here. Okay, I can use the main nav at the bottom. Every time you do something there, you might want to refresh the screen on the left. So for example, if I go into the category menu, the image on the left hasn't changed yet. I have this option in the center here to update my refresh the source and the screenshot. Okay, and that's kind of the process of navigating, driving the app from the right hand side and updating it on the left. There's an alternative version of that. So if I were to come home, refresh again, so I get my updated view, I can switch my navigation here to actually control the app from the left hand side, and you'll see that it moves on the right. Okay, or I can tap on categories there and it changes on the right hand side. So the choice is yours, but what I tend to do is use this left panel just to allow me to inspect elements, and I prefer to drive the app from the right hand side, refreshing the screenshots as I go along. So all you're going to do as far as gathering elements for your tests, you're going to get to the appropriate screen. So let's say I want to click on the electrical category to start with. You can see it highlights. I'm on the left hand tab here, select elements. I come down, I click on electrical, and it starts to effectively explore the DOM or the underlying structure to the application itself. You can see here I can click around, things are changing on the right hand side. But all I'm looking for here, and we'll talk about element strategy very shortly, but as I click on this here, all right, so it's the electrical link, and at the top right here I've got 3 things. So these are 3 of the 5 or 6 locator strategies we're going to be talking about. And actually what it's given me straight away is an accessibility ID. This is like a data test tag in the browser, something that should very, very rarely change and should always be reliable as far as test automation is concerned. So if you're inspecting your elements and you see an accessibility ID, that would really be your #1 choice. All you got to do is click on that, and it's going to copy that value to your notepad. You can paste that and save that for the time being. Under that we have something called a UI Automator element here. So this is the new UI selector, description electrical. So that is another type of element locator strategy using the UI Automator reference. And finally down here we have XPath. As with Selenium and browser-based testing, XPath certainly can be used, and in certain situations you may find that's all you've got, but it's our least preferable as far as having some of these options concerned. So of these 3, accessibility ID would be my #1, UI Automator reference would be my #2 element, and if I had neither of those, I would settle for the XPath. So all we're doing, as you can see, I'm navigating the app, so I'm going to click on electrical. So the flow of my test will be to come into this category. I'll click on computers, but before I do that, I would need to refresh my screen on the left. I would then come down here, inspect this element. There we go. We'll see electrical here. Sorry, it's not electrical. That's not the one we want. We want this one down here. So I can click on here, and sometimes you have to click around a bit to see where you get the most or the widest range of locators. So if I click at this level here, I then get an accessibility ID, a UI Automator reference, and an XPath. If I maybe come the next level down, now that would work, of course it would, but actually I'm limited to 2 types of locator strategy at that level. There I've got only UI Automator and XPath. If I went another one down here, conceivably that would work as well. And again, I've got 2 options there. So really, I want to have a click around and I want to find the level of the element that gives me the most choice of locator strategy. All right, so as far as my test is concerned, I will have copied and saved that element, and we'll bring it into a test shortly, which you'll see. So let's continue to click around back in the app. So I click on computers. Maybe this is a results page, so maybe I click on a particular product here, and again the process for collecting these elements is the same along the way. All right, I can come over now, I can refresh a screen on the left hand side. All right, I can kind of scroll down, and maybe I need an element for add to cart, so I can use my selector here. I can come down, click on add to cart. So this is the process of navigating from the right, inspecting from the left, and copying, saving these elements somewhere locally to you so you can reference them again in due course. And we'll see in a second how we build that into a test. All right, so that's how we use Appium Inspector. Okay, so we're going to add to cart. There's a few other things, so different types of elements, of course. So we've got elements we might be looking for by text of the button, for example. Down here, I might want to scroll to the bottom of the page by referencing this fulfillment options section on the page. I might want to increment the number of things that I'm adding to the cart down here. At some point when I add to cart, I'm going to want to assert that the things I think I've added to cart have been added to cart. I get this message here. I've got a count of products in the cart. All right, so things like that, which we'll look at in the test. Okay, right, let's look at the code then. That's how we do the inspection and the saving of the elements. Let's come back to the project that we created then. So of course, in fact, let's just get this app back to a starting position. So we have control of the app here, of the Android device through these controls. Come over here, I'm going to clear all, so it's going to take me back to the home screen. Cool. So let's have a look. So I've created a Cucumber feature. So Test Evolve makes use of Cucumber. So ergo we're using features and scenarios. All right, so I've created a feature up here. This is called my mobile app. The app is called Souk, as you saw. So mobile app, Souk. This is my checkout, and here's my scenario. Begin a checkout in the Souk retail app. So I've got 4 steps there. So given I search for a product, then I can add it to my cart. When I add more items to my cart, then I can begin the checkout process. Okay, so you saw how I was using Appium Inspector to walk through what that flow would be manually, effectively, inspecting, capturing my elements using a particular locator strategy as I go. But within this, I now need to start turning this into a test. So I have a feature scenario, I have steps here. And if you know anything about Cucumber and BDD, you'll know that I have a step. This is now my step definition, and I'm going to populate this with page, object, and method driven calls, if you like, that are going to outline the navigation of the application, the actions that I'm taking, the things that I'm asserting, or the parts of the flow where I need to wait for something to be present, maybe scrolling, and then ultimately checking that something's happened as I expect it to. So as we step to a lower level of this test now, this is what the test will start to look like. Now I've pre-written this against this app, of course I have, but I'll show you the kind of code that's involved. All right, so just as a workflow at this level, this is called what we call the middle layer of the framework, or you know, the step breakdown layer, if you like, step definition. So let's look at the given step. So the concept of searching for a product is broken down by these actions here. Okay, so when the app starts, I'm on the home page. I'm waiting until it's displayed for an electrical category component. I've chosen to scroll down here just so I can show you how you can do that with Appium and with Ruby. And then here I've got reference to a home page. So as I've gone through the app, I've decided there are many pages that I'm moving across. I want to reflect them within my automation project as all good kind of page object approaches should do. So I've identified a home page, I have a category page, I have a search results page, I have a product detail page, I have a main navigation, and I have a finally I have a at the bottom there a cart page when we get towards the checkout flow. So a number of pages, all right, so they're all represented with individual page classes. Within those pages, so within the category page, for example, I've built a select category method. All right, they're all fairly dynamic. You can see here that I'm passing values through, probably making reuse of this. So select category is in the given step, looking for a computers category, but actually it's further down here as well in this when step, where I'm actually passing through a different argument, so a different category that I want to select. All right, so let's just take a particular page class. We'll start with the home page here. All right, so I click through, and really the key thing to note here is what we are doing with our elements. So as I was inspecting with Appium Inspector, this is the kind of value that I would have retrieved from that inspection and capture process. Okay, so really on this home page I've got just two elements that I'm looking at, and this is going to be a repeating pattern across all of our pages. But I've declared here in Ruby a dynamic element, something that I can pass an argument to. So I've called it element by text. When I call it, I'm going to pass a value. So we'll go back to the step definition in a second. In fact, let's do it now. So select category. In fact, we're on the home page, aren't we? So we'll look at this one here. So home page. So select category is the method we're calling, and we'd be passing an argument of kitchen. So select category receives an argument and then passes it to element that can also receive an argument. So element by text is my element here. Here it's declared. This was the type of locator that we got from our Appium inspector. So I give it a name. I set it up to receive an argument. It's a UI automator locator. This is the string that I would have received, but I've made it dynamic by allowing it to receive this argument of text, so that when from the step definition I call homepage select category, I pass it an argument of electrical or kitchenware, for example. That same argument is then passed to the element itself, element by text with that argument, and then I'm then just calling .click. Okay, I explained earlier on that the preference would be for accessibility IDs as elements. So this is how we declare an accessibility ID if you are lucky enough to find them in your application. Okay, so element by accessibility is my name. I'm making it dynamic by allowing the passing of a text argument to it. That's the locator, the accessibility ID, and that's where it can receive the argument. So in this particular example, in fact, we saw it here earlier. So homepage, I'm calling the element by accessibility ID method. I'm passing electrical. That takes me here. There's that would be my electrical argument. I pass it to my accessibility element declaration here. Passes the argument through, so electrical, and it will be passed as an accessibility ID as my locator. So that's really how we declare these different types of locators we see when we've done the Appium inspection. All right, I've got a few other page classes that I mentioned. I'm doing different things in those. So they'll be tucked away in this pages folder. So when you open a new project in Test Evolve in the way that we did, you will start with a number of sample pages. We have sample tests, okay, but then you can, as you create your own pages, you can then tuck them away in this pages folder here. All right, so I've referenced this one as home page. You can see the various references to it there, instantiating as a new class. It's going to inherit all of our, in a Selenium and a browser world, our page objects, or in an Appium world, our mobile app screen objects. You know, I still refer to them as page objects, of course, but there you go. That's technically what it's doing. So we have some different methods on these pages. So we're selecting a category. Let's just look at our other pages. So we were then selecting a subcategory on the category page itself. We will then find ourselves in a search results page. So I've got a method here that allows me to select a product from my results. Again, I've got another dynamic page object or mobile screen object. So it's called page from grid. Same as before, it allows me to pass an argument. And when I was inspecting with Appium Inspector, this is, let's just move this out of the way. This is the reference that it gave me here. So that became my page object, but I made it dynamic and able to receive an argument. All right, so I've got a method here for selecting product from results. I've got a method here for verifying that the product is present. All right, so I'm not going to dive too deeply into the code, but just know that these things are, of course, probably fairly standard from an automation flow point of view, but it's just showing you the relationship from the elements that we captured to how we declare them within the project, within the pages within the project, and then how we use them within methods that we build upon those pages. So it's a search results page. I then have a product detail page. So I've got a method here for adding a product to cart. I have a method here for then verifying that that product has been added to cart. So that's probably our more complicated method that we have here. All right, and then I have a method here for incrementing the product count. So I make reference to a plus button, which was in the bottom left-hand corner of the application. And I'm going to say, right, I want to click on that a number of times that I determine. And that's going to be my +1 increment, +1 increment, +1 increment until I have the number in the cart or the number that I want to add to the cart. All right. Very, very occasionally, very sparingly as much as possible, I keep the use of a hard-coded sleep to an absolute minimum. All right. And as you're maintaining tests over time, you'll want to do your best to remove those wherever possible. Okay, try and make everything as dynamic as possible. I do have a helper file over here, so in fact, where is it? So I added a couple of things in here. So I added a scroll method, I added a scroll to text method, and then this is the type of thing I'm talking about. So I have a wait until displayed method here that, rather than me just sitting there waiting 5 seconds, is more dynamic than that. I can pass it a page, I can pass it an element. We have a predetermined argument that says, okay, we'll try for a maximum of 3 times with a maximum of 1 second sleep between those. Iterate 3 times, try and find the element. If you can't find it, then fail at that stage. So there's always an aspect of timing involved, of course, but something that's a little bit more dynamic, something that will return as soon as it has found something, is always better than just waiting indefinitely for a 10-second sleep. So keep those to a minimum. All right. So just coming back to the steps then, because that's really where these methods and pages come to life. So the flow of the test is homepage. We're going to select a category element. We're then on a category page. We're going to select a subcategory. We'll then be on a search results page. We're going to verify that a particular product is present. We're doing that with the passing of a string for that product. On that same search results page, I'm going to select that product from the results. So I'm passing an instance of the index of the images. So I'm saying index 1, which is effectively the second image or the second product. I've got a call to a scroll here. So scroll to text. I'm scrolling on the page to an element called the fulfillment options section. At that point, we're on the product detail page. So I'm going to add the product to cart. I'm going to verify that one of those things is now present in the cart. I'm going to use the main nav to go back to the home screen. I'm going to wait for something else to be displayed. I'm going to select the kitchen category. So following another repeat of the process there with different products. So select product from results. So a different product this time. This time I'm going to increment the product count. So +1, +1, +1. I want to add 3 of those to my cart, which I then do here. And I'm then going to verify that that collection of 3 items has been added to my cart. And then essentially we go through to the checkout phase, and I am going to complete some personal information on a form in the checkout. All right, simple as that. So that's how we start applying it as code within our tests. Okay, let's look at running this now. In fact, let's just kick that off. So I'm going to come back here to my feature. All right, let's click on the scenario itself. We'll click right click. I'm going to do run. This is RubyMine, of course, but click on scenario here. It's going to kick off this test. My config is set up, and I'll show you in just a second, to use this emulator on the right hand side. So let's just expand this. We'll see some of the stuff that's going on within the console itself. Right, so the first thing it's going to do is make sure the app is present. It's going to open the app on the emulator. This first step will take a little longer. There we go. So it's going to do everything I just outlined. Okay, so let's have a look. Electrical category. I'll scroll first, sorry. Electrical category, computers. Choose a second product. We'll make sure it's there, choose it. I think then we are going to scroll down to the fulfillment options section. We're going to add to cart. We're going to verify that message and that count. We're going to go to a second category now, second product. Incrementing the count, as we said, adding that to cart, making sure there's 2 products within the basket now. I'm going to go to checkout. I'm going to make sure that page is loaded correctly by referring or waiting for the email field, and then just starting to fill out some fields within that personal info form. All right, there you go. So that's the test actually running. That's been successful. If we just look at some of the console output, of course, you know how the type of information you output to console in your test is entirely up to you. But I did some things here just to say that the electrical component was visible on the screen. This was one of my assertions, making sure that the product added to cart message and the dynamic cart item count, 1 for the first time, 2 for the second time, were both visible. And this was when my wait until displayed method. So this was on the personal address or personal information form. Email not found on attempt 1, element couldn't be located. It then tried again up to a maximum of 3 or 5 times, I think, and it then said email is visible, and then it proceeded to fill out that form. All right, so that test ran. So the configuration to do that, you can come over here within our default config in the project that we opened. A few key things in the configuration file here. We are setting this test type up to be a mobile_app test. All right, that's the first thing we're going to do. In mobile app, in the configuration file, we're setting it to be a local device. We have the app path similar. Well, the app is in the place that it was when we used Appium Inspector to inspect it, but I've got reference to that location in my project within this configuration file. Okay, so I get that absolute relative path, absolute or relative, and I can put that in this app path parameter here. All right, this is local device. I've got some information saved against my local device itself. So UI Automator 2 is my my engine. Pixel 7 is my emulator. It's Android. It's API level 36, and it had a device name or UDID, unique device identifier, as we saw from doing ADB devices of Emulator 5554. So I add that information to this mobile app.yaml config file. That's how it can target that emulator and run the test successfully. And then finally on reporting, I want to enable some of our dashboard reporting in Test Evolve Halo, which I'm going to show you in just a second. So in dashboard, within the reporting YAML, I set that to true. My project ID is my project 1. I've got a label that I use. Labels give our test output a sense of purpose and allow them to find them in our reporting platform. And I have a unique key which has been created just for this webinar, and it's now invalid. But so when I've run that test, if I now come back across to Halo, so this was where you first registered your organization. So if you come back to your URL and now sign in, I've got a run here for a test that I just did. And here's the output of my test itself. So I'll just move the emulator out of the way now. We don't need that right now. So your runs, when they first come through, you'll see them on the home screen in the latest runs section. You'll also find them in the unassigned labels page. So we have plenty of other webinars and documentation that talk about how you configure and set up your Halo instance. But just know for now that as soon as you run a test, you'll find it in your latest run section. So this mobile app webinar was the test that I just ran. 100% progress, 100% passing. All right, so let's just look at that. We only had one scenario, so one passed, one total scenario. That's how long it took to run, 1 minute and 38 seconds. I've been running it a number of times earlier on as I've developed that test, and I'll show you a browser stack version in a second as well. But we have a history of runs down here in the run history table. We can see here, excuse me, it's a local device, it's a Pixel 7, it's Android. Everything we just said, the way in which we set up the configuration file, you see that in the run properties at the top part of the page here as well. And then I have a click through to my actual results, and this is going to show at a lower level the test that I just ran. Complete traceability, transparency to our test, our feature, our scenario, the steps within our test. So really, really useful reporting that you can share with your kind of wider delivery team, your product stakeholders. So given I search for a product, I can add it to my cart. When I add more items to my cart, then I can begin the checkout process. So within a very short matter of time, we've opened a new project. We've opened up an emulator. We've used Appium Inspector to gather our elements. We've written a fairly simple but still comprehensive test using the elements that we captured. We looked at some kind of dynamic passing of arguments to target certain elements. We had some dynamic wait until displayed methods to make sure excuse me, to make sure the app was in the right state before we proceeded. And then with our configuration set correctly, we targeted the test to run against the emulator itself and then to output the test results to your Test Evolve Halo dashboard platform, which you can now see here. All right, so there's one further thing I'm going to do. We talked about what if I want to run this against a service like BrowserStack. So I'm just going to come back into my mobile app configuration file. So that's over here on the left-hand side. And rather than running this as a local device now, I'm going to run this against BrowserStack. Now, of course, that relies on me having a BrowserStack account. So I have a temporary account for which I can store the credentials in my BrowserStack file. That will also be invalid by the time this webinar goes out. Okay. And all I'm doing, the configuration remains as a mobile app test. In mobile app now, the source has been changed to BrowserStack. And my reporting, I'm keeping exactly the same way. All right, so I'm going to run that test again. And the only difference is it's going to target, I'm not going to be using the emulator this time, but it's going to target BrowserStack as the device. So we'll just come back to our mobile app, our checkout feature, right click on the scenario, and I'm just going to do run. So it may take a little longer to boot up this time because it's got to authenticate with BrowserStack. It will tell you in the logs exactly what it's doing. It's going to delete and manage and upload the apps on your BrowserStack instance itself. All right, so what I can do now, if I come to the browser, I come over to BrowserStack. We'll just keep check of where the test is. So it's managing the app on the device itself. We left the reporting going, so what you'll actually see in Halo is that it's already running that test against BrowserStack, so a new instance of that test is underway. Get rid of this agent. Let's come back, just see where we are on the test. Right, and now we have this test running. Okay, so test running a few seconds ago. And here it is. So I did have some other parameters I can set for my device selection. So obviously the purpose of using something like BrowserStack would give me access to a much wider variety of devices. So you can see down here, I've set up my config to target a Samsung Galaxy S22. All right, that's the main difference. Here's a version of the test that I ran against BrowserStack earlier. So you'll see that when that test runs and finishes, you'll actually get a video of the test. We'll look at the one that's running here. I can click into this. I won't get that video output until the test is finished itself. So if we come back now, so we can see we're still getting some of the debugging information. So we can see the test is running. Here's my emulator. Of course, I'm not using that, so it's sat there. It's not actually doing anything. But what's quite interesting here is that we're really just getting the logging information, but there's nothing really to see until the test completes in BrowserStack. But I'll come across now. And of course, it's got to send the close and the finish commands through to BrowserStack before this test will be deemed complete. So let's just wait for that to finish. So it's going to take a little longer to run on a cloud service like BrowserStack than it will on a local emulator. But we'll wait for this to finish. And while that is, I'll just show you the video output we saw from an earlier run. All right, so this is what you can expect to see in BrowserStack, just showing you the execution of your test on the device that you've chosen. All right. It's exactly the same. It may render slightly differently, may look slightly different. In fact, that screen does. That looks different to me. But I was on a Pixel 7 locally, and this is a Samsung S22. But the test will run. in exactly the same way. But I think this is failing, and it's actually a bonus that it is failing, because there's a couple of things I get to show you. Actually, it highlights the purpose for doing cross-device testing, right? So something that worked perfectly well on my Pixel 7 emulator, for some reason, is not working here. And actually, it would appear to be just because we have that keyboard. So actually, there is an option within Appium. You can say hide keyboard. So I think when we are sending keys to these fields, it's invoking the keyboard and then stopping me getting to the next field. So that's almost certainly why it's failing. But that's fine. We saw the test passing on the local emulator. So coming back to Halo, we now have a failing mobile app webinar test. Let's have a quick look at that. Let's get rid of the emulator again. All right, so we have the run history. The one that passed was the one we ran locally. We've now just run this one against Browser Stack. You can see the run properties are different. Browser Stack, Samsung Galaxy S22. And this one actually failed, so it's quite useful to drill down, to click through into a failing test to try and understand why that's failed. Okay, so against Browser Stack, this has run, well, this has failed a couple of times. It passes 60% of the time, so the times when it's not passing, they look to be against the Browser Stack circumstances. So we have a screenshot here, we can open that up, we can see where the test was as to why it's failing. And sure enough, there you go. That's the screenshot we saw from the video in Browser Stack. We have that in our reporting as well. All right. So just finally, I've opened up Visor here. Now, Visor was an optional extra. All right, it's just if you want to show a physical device on screen, like I'm about to do now. So if I want to test on a physical device, I connect my device to my Mac. In this situation, I run ADB devices again. So ADB devices up here, as you can see. And I now get another device reference, or a UDID. All right, so this is the UDID for my physically connected phone. In this case, a Samsung Galaxy S23. All right, so similar to how we connected to the emulator. But what I'm going to do, I'm going to knock this back to be a local device. This was where I set any Browser Stack configuration that I wanted as part of my test, or the device I was looking for. And now, because I'm working on a physical device, which is this model here, I'm going to add that to my local device configuration, along with the UDID that I've just got by running ADB devices from the terminal. Okay, if I just open Visor now, so I'm connected, I can see reference to a phone here, so I click on the play button, and it's going to give me a visual representation of my physically connected device. Okay, so let's just come here, we'll kick off that same test again, we'll come back to Visor, and let's just watch that test running on a physical device. So it's going to go through the same process as it did on the emulator. It's going to ensure that the app is pushed to the phone. It's going to open the app. This is all on the physical device, so I can see it on the desk beside me. You guys can see it on the Visor representation, but that's a physical device. S23, so I guess it's going to render much the same way as the S22 did in Browser Stack, which could well be different to the Pixel 7 that we used in the emulator. Excellent. I'm also outputting the results of this test through to the Test Evolve Halo dashboards as always. So it looks like this is probably going to fail in the same part as the Browser Stack test did, but that's fine. So that's just run. Let's quickly step across back to Halo. Here we go, mobile app webinar test. For the version that we were just running. So now you'll see that some of the configuration that I passed through. Samsung Galaxy S23 is present in our reports. It's still considered a local device, of course, but this most recent iteration failed. It's still running at the moment, but yeah, that hasn't yet failed. I'm going to stop that. But as you've seen, when that does fail, you will have your screenshot to look at to come and do your troubleshooting, analyze why your tests are failing. In this instance, as we've seen with BrowserStack and the physically connected device, it's going to be an amendment that I need to make to the test. I've looked at that. I can see it's not actually a bug with the device. It's a difference between a Pixel 7 emulator test where the keyboard isn't on display and I can send keys to those text fields, as opposed to here where clearly that keyboard's been invoked and is blocking the interaction with the next element. All right, that's going to be it for today. So just a word, or just reiterate on element selection strategy. So as we saw, if you get the chance to use accessibility IDs, you should do so. They are like data test tags in a web app. They're designed not to change. Their primary focus, of course, is for accessibility reasons, but that gives us a very solid hook for an automation test as well. So definitely the most reliable. Something you should talk to your developers about, making sure every element you need to do something with is represented with an accessibility ID, ideally. We didn't see any resource IDs today, but they are something you can inspect and extract with Appium Inspector. Okay, so they are certainly stable. They can change between versions of the app, but another good option that you have. Probably the most common, if you don't have accessibility ID, is then UI Automator. We saw these. We've used them in our example today. They're good for scrolling as well, as we've seen. And then finally, your XPath, really, albeit we had a couple in this project, they're the last types of locator strategy you would want to use, really, for the same reasons with browser-based web app testing. Something about the layout of that app changes. Those XPath are no longer going to work. Okay. And class name, really, just avoid those at all costs. They're just not reliable, not unique enough. So in some regards, worse than XPath in this situation. But there you go. So just something to think about with your element selection strategies. Okay, so we looked at emulator testing, we looked at physical device testing, we looked at cloud-based real testing with BrowserStack. There are other vendors, of course. You have Source Labs, you have Cobaton, you have Lambda Test, so maybe you're already working with one of those, but just to show you how quick and easy it is to direct your test from a local device or an emulator over to BrowserStack, giving you that kind of cross-device coverage then, just making simple changes in the configuration, and then ultimately outputting all of your results to the Test Evolve Halo dashboard platform. So if you've been following along with this webinar and you've signed up for evaluation, this is what you'll have access to for 30 days, fully featured, free trial. But it means you can be up and running, manage your APK file within your project, use Appium Inspector to fire up the app, inspect your elements very quickly, start writing your tests with reference to those elements, and having a range of options when it comes to running and reporting on those tests. All right, so I hope that's been useful. Cheers. That's going to conclude our webinar for tonight. Thank you so much for joining me today, guys. I hope it's given you a really good, solid starting point for automating your Android apps with Appium, and tonight, as you've seen, with Test Evolve. So if you've been following along, or you want to get started, or you're watching this on repeat, then we have a free 30-day fully featured evaluation. So we showed you that sign-up process at the start of the video. So just go to testevolve.com/try to get up and running. Our documentation you'll find at testevolve.github.io, and equally feel free to reach out directly if you have any questions at all. We are always more than happy to help. So if this has been useful, please give us a thumbs up, a like, and subscribe on the video. And if you're curious about what else Test Evolve can do for you, from browser API testing to lighthouse auditing to accessibility testing to visual testing, it's got it all covered for you. So please check out the website.com for any other information. So thank you again for watching, and have good fun and good luck on your mobile app automation journey. Until next time.